Hi, welcome to section 5.2, Rectangles and Area Properties. In this section, we're going to talk about composite figures, their properties, regions with holes, and then their properties. So here is our opening question. How many square miles cover the state of Utah? Now, I picked Utah for a reason. If we look at Utah, if I wanted to figure out the area inside of Utah, I could count. I put it on a grid so I could technically count all the little squares, and then I take all the little squares and I take it times 676 square miles. I could do that. I don't want to. To me, it's going to take a little bit too much time. So there's another method I could do, is I could take the state of Utah and I could break it apart into two rectangles. And I could label each rectangle A and B. And so I could find the area of each and just add them together to find my total. So area of A, well, the area of A, which is the top rectangle, is equal to 156 times 78. If I type that in my calculator, I get 12,168. Okay, so now I'm going to look for the area of B. And that's 273 times 286. Type that in my calculator and I get 78,078. Well, now all I have to do is add those two guys together and I'm good to go. So I call that area of Utah is equal to 12,168 plus 78,078, and when I add those together I get approximately 90,246 square miles. Now I'm pretty sure that my numbers are a little bit off, but they're going to be pretty close to the actual area of Utah. Alright, so let's look at a problem that's a little bit more complex than Utah. Find the area and perimeter of this region. And I drew the picture twice, and the reason I did was because we do things differently. Some people might take this figure and divide it up into three rectangles like this and say, well, I want to find the area of rectangle A, B, and C. Another person might say, well, I want to do it like this. I want to break it up like that. And it doesn't matter. And they can say, well, this is A, and this is B, and this is C. You're going to get the same answer. So let's look at the first way. I want to find the area of A. Well, area of A is pretty simple. Length times width. So the length is 20 and the width is 6. So area of A equals 20 times 6, which is 120. Right. Now let's find the area of B. That's a little bit trickier, so I'm going to outline B. There's my rectangle for B. Alright, first of all, I don't know the length. This bottom right here. But here's how I find it. I know that my total length on the bottom, I know that that's 20. That comes from here. If I move in and take this little piece out, I know that this little piece is 4. That came from here. So in other words, if I take 20 minus 4, that'll give me my 16 inches, which is right here. So my length is 16. Now we're going to do the same for the height. The height is 12. But if I take away this piece, which is 6, and I take away this piece, which is 3, 12 minus 6 minus 3 gives me 3. So this is 3 inches right there. Right? So area of B is equal to 16 times 3, which is equal to 48. Alright, now we just gotta find the area of C. And the area of C, well, length is 20 inches. 20 times 3. And so that's 60 square inches. So now we just find our total. So area of my total thing, all we do is we add them up. 120 plus 48 plus 60, and that gives me 228 square inches. Alright, now don't forget about the second part, the perimeter. Perimeter deals with the outside. So I'm walking on the outside, so I'm going to shade the purple, and it's right here, that's 12. The bottom we found to be 20. First height is 3. Then we went in 4. Then we went up 3. Then we went out 4. Then we went up 6. And then we went back over to 20. So when I add all those together, I should get 12 plus 20 is 32, 35, 39, 42, 46, 52. I got 72 inches. And so that is the perimeter. Alright. Okay, so now let's do the area the other way. Okay. So if I want the area of A, I know the height is 12. Easy enough. To find the width, I simply take 20 minus 4, because this is 4 right here, so that makes this 4, so that makes this 4. So then this will be 20 minus 4 is 16. Alright, so area of A is equal to 16 times 12, which is equal to 192. Area of B is 4 times 6, which is 24. Area of C is equal to 4 times 3, which is equal to 12. And area total is equal to 192 plus 24 plus 12, which is equal to 228 square inches. Alright, so that's how you do it. Now let's put things into mathematical terms. So here's our properties for composite figures, what we just got done doing. And it says this: for any region R, the area has to be greater than or equal to 0. So in other words, the area is always bigger than 0. You can't have an area 0, then the figure won't exist, and you can't have a negative area. That's all that statement is saying. Don't think too hard on that one. Number 2, congruent figures have equal area. If the figures are the same, then they have the same area. So if I have two figures, here's A, and I'm going to say that, hey, A and B are exactly the same, so that means the area of A is going to equal the area of B. Right? The third property is this: if two figures R and S intersect only in vertices and sides, then their areas add together. In other words, it's just what we got done doing. If I have a figure, and I'll make the figure look like this, and I'll call this R, and I break this apart, and here's S, that's telling me that my area total, that's what this means, R union R and S together, is equal to the area of R plus area of S. So that's just what we got done doing. It's just we use different names. Okay. Alright, now, and the last one is the area of a rectangle is length times width, but that is something we all knew. So now that's when we have two figures that we put together. What happens if we have a hole in the middle? What that means is if I want the area of the shaded. Basically what you're going to do first is you're going to find the area, your total area of everything. Okay? So that means I'm going to find the area if that little block wasn't in the middle. And I want the area of everything. So my total area here is going to be 14 times 10. Because length times width. So that's equal to 140. Oops. Alright, I'll get rid of that. But the thing is, I don't care about the middle. So here's my hole in the middle that I don't want. It's kind of like I'm cutting it out. So what we first have to do is we have to first figure out the length of my hole. Well, I know that the total distance is 14. But I'm going to take away 3, and then I'm going to take away my 2 that's on that side. So basically, 14 minus 3 minus 2 will give me 9. So this is 9 meters. Alright, and I can erase that part. Gotta do the same with the height. So in other words, my total height is 10, but I gotta take away 2, and I gotta take away 2. So 10 minus 2 minus 2 is going to be 6. So this is 6 meters. So now I find my area of my hole. Area of my hole is 9 times 6. And that's 54. So if I take my hole out of there, I'll find the area of the shaded. And that's what I'm looking for. So area of the shaded equals area total minus area of the hole. So that's going to be 140 minus 54, and that will give me 86 meters squared. So that's how you find area of shaded when you have a hole involved. And here's those properties. It basically says the area of the region that we want. So in other words, the area of the shaded is equal to everything, which I called the total, minus the area of the hole. So here's our statement. Area of the shaded is equal to everything minus the hole. Alright, so that's section 5.2. Thank you.